One, two, everyone.
Good morning.
Thank you all for coming out this morning. So hopefully we'll have a chance to learn some things. I'll share some things, and hopefully you'll share some things, and then we can learn together. Is that all right?
Yeah.
Great, great. And hopefully, I think we're going to get this done. We're going to do a couple of experiments, some things that you'll get a chance to utilize those powerful brains that you have there, right? To help to answer some questions. But before I start with that, we want to talk a little bit about what solar is. Does anybody know something about solar power? Oh, I see. Come on, go ahead.
Solar is when you use heat and the light from the sun to make energy using solar panels.
Yes, yes, yes. The sun is a critical factor. We need the sun because the sun provides the light. And we're going to talk a little about a concept for photovoltaics. We'll talk about what that means. But anybody else, before we get started, anything else? Please, please.
Solar energy is renewable because it comes from the sun.
It comes from the sun, exactly. So one of the things that we talk about is making sure that everybody has an opportunity to have access to resources. We'll talk about that for things like what we're going to talk about today, like solar and renewable energy, energy efficiency, etc. And then there's something else called environmental justice, which is how do we protect our environment to keep it healthy, right? Because sometimes some communities get impacted, they get hurt by bad things in the environment more than others, right? And some communities, have any of you ever seen a factory, and driven down the highway, a factory with smoke coming out?
Yep.
So what do you think happens with that stuff when it gets into the air?
It causes climate change.
It does cause climate change, it can be a factor, yep. It can be chemicals too, which is another thing. Somebody said something else over here, I think I heard it. It does what? It affects our air, and then what is that? What do we breathe?
We breathe in different toxins.
What do we breathe? We breathe water or air? So what happens if the chemicals in the smoke and everything goes into the air?
It gets polluted.
It gets polluted, and then what do we breathe?
Polluted air.
And what does that do to us, you think?
It could cause us to die because of
Yeah, it hurts
us.
the lung. Asthma, cancer, emphysema, and really some pretty bad stuff. I don't want everybody all scared, but you know. But we got to be concerned about these things. And that's why you are here to help us to make a difference in this world with what we know and what we do. All right, really important. So, we talked about renewable energy. You knew what renewable energy was, and so now I'd like to just move into non-renewable energy. So renewable and non-renewable. So how many have ever heard of oil and petroleum products? Oil and petroleum products. Oil? Who's heard of oil? All right, so I know everybody got that one, all right. So that's non-renewable. How about gasoline, diesel fuel, propane? All right, so those are all non-renewable. Natural gas. And the reason they say that is because there's a certain amount of it in the earth, in the ground, and we just keep using it, and eventually it's going to either run out or it becomes so expensive to get it that it's really not good, or it becomes very, very unsafe. Like when they go way out into the ocean and they drill, because they have to go further and further to find it, and then they start drilling further and further in the ocean, and then when something happens, it becomes really, really bad. It's hard to stop it, right? And it just gets all into the water. It's bad. Bad for the fish, it's bad for our environment, it's bad for us because we drink water. So nuclear power as well. There's some things with nuclear power that create, anyone ever heard of radiation? Yeah, well, nuclear power has some things, some side effects. They have to find ways to store it, and that's a problem. So we do have renewable energy like solar. How long will the sun last? Anybody know how long the sun's supposed to last? Hey, you got it.
2 to 3 years.
Well, probably a little bit longer than that. That's all right, but that's a good one. That's a little longer. It's a long time. The sun lasts a real long time. Okay, okay.
3 to 4 years.
It's a big number. I'm going to tell you. Okay, please.
5 or 6 billion years.
Hey. 5 billion years, a long time. So we have sun for a long time. Renewable. So geothermal comes from the ground. It helps to heat things. You know, steam can be used to drive engines, right? So geothermal, we can stick that in the ground. Really, a lot of places can use it, and it helps to keep our houses regulated, really good and clean. Wind, we got to find where the wind blows. We can use wind to drive turbines, right? They spin, and they generate electricity. Hydro, what's hydropower?
Using water mills and using water to spin mills to get energy.
We're going to get ready to do some exercises in a little bit, but I want to go over a couple more things. So we talked about 5 billion years. So everybody had that. The sun is like about 5 billion years, right, for the sun, right? Do you think that's a pretty good amount of time?
Yeah.
It's a good amount of time. Did you know that enough solar energy falls on the Earth's surface in 1 hour to power all of human civilization for a year? Enough solar energy falls on the Earth's surface in 1 hour, right, to power all of human civilization for a year. Now, when we say human civilization, it's not just like one house, it's like everything that we do around the whole planet, right? That's how powerful the sun is. So, do you think we're using enough of the sun's resources right now? Say no. That's absolutely correct. Yeah, we're not. We could use a lot more. And because it's renewable, it means we could power the whole world. Technically, we really could do that. And we could power our whole country with the space in one state, and not even a whole state. So it's really amazing what could be done. Solar basics, we talked about this word. Can you say photovoltaics? Photovoltaics.
Photovoltaics.
Okay. And so photo meaning light, and voltaic means it produces voltage, right? So photovoltaics. So that's what we call solar. You can either say solar power, or photovoltaics, or you can say PV. You'll hear people talk about solar, they'll say PV. So photovoltaics, it's a short way of saying that. Here we go. Photovoltaic PV systems convert light directly into energy, or electricity rather, using semiconductor technology. So, pass these around. Semiconductor technology. You know that solar is basically made out of silicon, right? And silicon is basically sand, and it's one of the most plenteous materials on Earth. We have a whole bunch of it across the whole planet, so we use a resource that can be found really easily. This is a solar cell, a small one, a very small one. And I'm going to show you in a moment a very big one. But the concept is the same, right? You have a positive, a negative. You have the sun, it's the cell, and there's electrons that are knocked loose, right? And they are picked up by wires that are on the cell, right? And those wires, there's a circuit, okay? Something that means it's continuous. And these wires then allow us to plug in to make something happen. We have this electricity that produces power that we can run things, right? So if I take this and connect it to something, when the sun is shining on it, and we have the photovoltaic effect, right? Light creating voltage, we are able now to do things. So on your building, I'm told that you have a 121 kW system, a lot of modules, a system on this school. So you're getting solar power right now from this system that you have on your roof to power your school. Did you know that?
Yes.
Please.
We in our class we learned about like electricity, almost like the for the positive and the negative.
Oh, great. The positive, negative, you're right. You got it. That's what's on there. And if you see on the back of that, this is interesting. So the solar is on your roof. It's generating electricity because the sun is shining, and it's connected through wires to a plug. You can plug in and run things. We call that a load. Something that's powered. Can you say this word, load? So when you power something, it's a load. So a light can be a load, right?
Yeah.
A light, your stove, your refrigerator, an iron, okay? So let me just give you a sense of this. So there's something that we can't see, they call them photons. When they're coming from the sun, photons. particles of light. We can't see them, but they're there. And when they hit the cells, I mentioned, those electrons are excited. And then they're picked up by these wires, right? We got the circuit, and we're able to then power something, a load. Okay, so remember what we talked about. So you see the diagram over there? So here's one of the cells, right? This is going to be our sun for the day. Pretty bright. Did you see that? What's happening?
The light is turning on.
So this is what we call, again, the photovoltaic effect. So it doesn't just have to be the sun itself. It's light, right? Light. And we can see that when the light is on, our sun, the morning, what happened this morning? The sun rises. So the sun rises, and then boom, we got power, right? And that's what's happening with this school. This right here is a real small version of what you have on the roof of the school. And so now you have enough power on the school to help to power the school itself. That's pretty big. There you go, right? And we're going to talk about this in a little bit. Okay. Thank you so much. What's your name? Who? Clarissa. Thank you, Clarissa. Hey. So, what is this?
Soccer ball.
Oh. I thought it's the sun. A soccer ball. What made you? That's the sun. It's not the sun? All right. Could it be the earth?
Yes. Yes. You can pretend it.
You know what?
You can pretend it.
We'll pretend. Let's pretend. You know that? You got the whole world in your hands. It's not something that's kind of just a song, but that's why you're crazy.
The whole world in your hands.
It was a joke, but probably.
Little thing.
Thank you. Okay, so here we go. So let's talk about the sun and the earth. So this is a pretty bright light, huh?
Yeah, it's really bright.
We're going to talk about this too, batteries in a moment.
We're talking about batteries too.
So if we're in, does anyone know what hemisphere we're in? What hemisphere are we in? Hemisphere. If this is the earth, what hemisphere are we in? Please. We're in the eastern part of the country. What hemisphere? So like, if we have a sphere, this is a circle, a sphere. If we cut it in half, it's a semi, right? It's semi, right? So then we have, what hemisphere? What hemisphere are we in? What hemispheres? For the planet has hemispheres. There's two of them. Okay, right? We're in the northern hemisphere. You got it. So we're in the northern hemisphere. So
Northern and western.
What's that?
Northern and western.
Well, northern and southern. We'll be in the north. We'll use northern for now. We'll say we're in the northern hemisphere. We're in the northern hemisphere. So the sun is shining, right? And does anyone know, does our earth rotate at all?
Yes.
Does it tilt at all?
Yes.
So what happens, you think, in the summertime? So remember, we're in the northern hemisphere.
The sun.
So in the northern hemisphere, in the summertime, are we further away from the sun or closer to the sun?
Closer.
All right, so watch this. So if we're right here, right? Here we are, right up here in the north. In the wintertime, we're further away from the sun. In the summertime, we get more sun, right? Because the earth actually, the tilt actually changes. It's circling the sun. So what do you think that means for us in terms of if we do solar, which way do you think the sun needs to, the solar needs to face to get sunlight most effective? This is a tricky question. So if we're in the northern hemisphere, right? In the wintertime, our earth tilts further away from the sun. In the summertime, it tilts closer to the sun. Which way do you think we should point solar to get the most solar? Take a guess.
And during this that we need
In the
the
summer.
sun in the summer, because in the winter we have less sun, but in the summer you have more sun. That means more power for us to use everyday items.
That's very true. So let me just tell you this one. We want to point it facing south. The ideal orientation is for it to be facing south, right? And we're going to do a little experiment so you can kind of see that, the difference. So if the sun is here, if we're away from it, we're going to get less. If we're coming towards it, we get more. In the summertime, and various times of the year, summertime in particular, we get more sunlight. We almost all the time want to have solar facing south. We can go east and west, but never north. Why do you think we never put solar on north, facing north? please.
Cause if you put it facing north, then we don't get a lot of power because there's not a lot of light facing north.
Exactly. We're like facing away from the sun effectively. We're kind of like, if the sun is shining this way and I'm going to get power by being pointed to the sun, if I turn away from it, nothing's going to happen, right? So we want to face towards the sun.
Oh.
So what do you think this is?
A solar panel. A solar panel.
Oh God.
It's a table,
It's a solar panel.
a doorway. It's a solar panel. Solar panel or module. So I'm going to give you an experiment. So you can put your thinking cap on now. This right here is like that. Can you hold that one up? Hold those up so they can see it. They're very similar. You see there's two wires on the back, right? And you got two wires here. And can someone come up here for a moment that has really good eyes? You got good eyes? Come
I
on
good
up.
eyes.
Yeah, good eyes. Come on up. Well, both of you, come on up. Come on up.
Excuse me.
So I want you to look at this. So we saw that this one is just a big, big version of those small ones, right? What do you see right there? There's a symbol. What does that say? You see that? There's two of them. One right here and right there.
A negative and positive.
Okay, say that again, please.
Negative and positive.
All right, so what did we say exists on those smaller ones?
The negative terminal and positive terminal.
Exactly. So this is, again, literally just a big, big version of what you have there. So this is one of the things that's really amazing about solar. If we want more power, we make the modules bigger, right? So now you have enough of these on your rooftop to help the power of the school. I'm not sure what percentage of it is, but it's probably a lot. 121 kW is probably a lot. So this is what's on your roof. It's modules like this. So thank you so much. What's your name? Alyssa, what's your name?
Caden.
Caden and Alyssa. Hey, let's give us a hand. All right, so here's a little bit of experiment for you. This is a 300 watt module.
Well, class
300
comes in.
watts,
Class comes in.
right?
Yeah.
So, how many of these are there? How many of these cells? Somebody tell me how many cells there are?
60.
How many?
60.
That's pretty good. So this is a 300 watt module.
I did multiplication.
How many lines are there?
I thought it was 62.
This is about 5 per cell. Great question. So it's 60 of them. I said this is a 300 watt module, right? So how many watts do you think each cell are? So each cell, this is a 300 watt module. There's 60 cells that make up this module. So how many watts in each one of these individual cells?
3.
Gotta do some math.
It's the math part. Just a little
What
bit.
but can you repeat that, please?
Okay, so this is 300 watts. This whole thing is 300 watts. You all were absolutely on it. You said that this has 60 cells, right? You're right. You're absolutely correct. Now, what voltage is each of the individual cells? There's 60 of them. This is 300. This total thing is 300. There's 60 cells. How many watts per cell?
5. No, I did the math while I was talking. It was 5.
Okay, say it again.
5.
Okay, he said 5. Say, are you sure? Are you sure?
I did the
Are you
math.
sure? Oh man, you're absolutely correct.
5.
You're correct. It is 5. You're right.
See, I knew the answer because I did the math while you was talking.
You did the math right. Just say it out loud. 5. Like it's 5.
300.
Yeah, like that. It's 5.
300
You got it.
divided by 300 divided by 60 is 5.
So let me give another problem to think about. So I'm going to put a solar system on my house. My house is going to have 300 watts. It's going to be what we call 300 kilowatts. So how many watts in a kilowatt?
5.
Oh, this is a hard one. So kilo means how much? Kilo. 1,000. 1,000. A kilowatt is 1,000, right? So let me ask you this: 3,000 watts, right? So I'm going to have a system in my house with 3,000 watts. How many of these would I need in order to put together a 3,000 watt system? Now remember, this is 300 watts. One of these is 300 watts. And I want to put together a 3,000 watt system. How many would I need?
10.
Are you sure?
10.
Are you sure?
10.
Say it loud.
10.
10. Absolutely correct. You get it. Correct. 10. Say it out there. So yeah, we need 10
I
of these to
said
make a 3,000 watt
I get the
system.
credit.
Whereas one more question. and we'll move on.
We both know this stuff.
Who's saying about who they knew about parallel? So tell me about this.
We both know
So,
about it.
what's the difference between series and parallel? In series, we said that the voltage adds and the amps actually stay the same. The voltage adds and amps stay the same. But in parallel, what's different about parallel wiring? Are the amps the same? Are the amps add? To the, yeah, please go ahead, sure.
What can we do? What can you repeat that, please?
So in series, the voltage adds and the amps stay the same, okay? The voltage adds and the amps stay the same. And we wire in series, it's like our circuits. But in parallel, when things are wired in parallel, what's the difference?
That series uses more power, uses less power than parallel.
Well, please.
But if you break a piece of the circuit with the parallel one, you can still make it go because there's two connections.
Man.
Watch now. See how it's on there? Now tilt it. Start tilting it at different angles and watch this. No, leave the fan and tilt the solar panel. Remember the 3 different angles he was doing? Shh.
So black is negative, right? Are you on the negative?
I'm gonna try to do it like tilted vertical. So the sun's up here. Look at the fan now. It's slowing down. It's like stop. Now tilt it again. Is it gonna go? See? And now tilt it flat. See what happens. Oops, sorry. See it's slowing down again? And then tilt it back up. See if we can pick it up. See?
That's in our eyes. So if this here is starting, it's heating up. Hey. So what is happening? Energy from the sun is what? Making it move as the panel absorbs it, and we connect it to the panel, and it's transmitting that energy to the fan. So it's the way that we can, one, energy from the sun goes to the panel, and the panel stores it, and then you pull the energy into whatever it is. It might be a heater. This is a fan. So that's how we can capture it.
So you're negative, right? What happened? It was 1.5 or 1.4 now. What happened? Yeah, it's getting bigger, smaller? Bigger, right? Yeah. So it's hard to keep it straight, but it's definitely, before did we have any numbers that were in the 2s or the 3s? No, right? So now it's in the 3s. So now we have one more battery. What do you think is going to happen? I think it's going to get higher. I don't know, let's see. Okay, so again, remember positive to negative. And good job holding it together. Ooh, so now what happened? Of course, right?
Are we close to 4.5? Give or take? 4.75. Yes, you are. We have 4.5, 4.74 volts of energy coming out of those 3 batteries. Not bad. Now, eventually, the four of you that don't have anything in your hand, you're going to do this also, okay? So I want to make sure everybody gets their hands. All right, good.
Let's try it again.
All right, so again, switch yours. Positive, spread that way.
Bill, we need to repeat
So
it.
what two batteries?
So what does everybody want to do? Do we have enough? What do you want to try again?
Three, okay? So I just want to get this with this.
No, don't write it upside down.
This is the way that we're going to stick.
Can I use a different colors? Black is.
So you want to write this one?
Yeah, me.
All right, let's put this down.
Every time we added a battery.
I can't imagine what it would take for you to do something. Ready? Okay, move over so that he can, right.
Hour, right?
Okay, he gave us the first one. The more sun you have, more sunlight, the more power.
Infinity. Yeah, times infinity. It'll catch a snowball.
Just because you have bad handwriting.
All right? Come on, team. Is everybody on the team? Come on, team.
Come on.
Don't be shy. You don't want to go with them. All right. But you're part of, I'm looking at you. I see it. You're part, I see you. I see you. All right. So what you're going to do is give us a reading of what you've done, what you observed. You did 2 experiments, if you will. So can you tell us what you learned from the first one? Which one did you do first? Okay, so do the solar and then the battery. So tell us what you got all these shows. Number 1.
When we started the battery died.
That's true, absolutely.
When you remove the solar panel from the light, the fan speed slows down.
Solar panels can create energy without harming the environment.
Nice, nice. Very good. Okay, you're working out the loop here. You got it. Great job. All right. What about the batteries?
Solar panels help save energy.
Yes, yes, yes. Great job.
The more batteries, the more they save for energy.
Great, great.
The less batteries, the less energy they'll save.
Excellent. Hey, let's give them a hand. Great job. Way to go, way to go, way to go. All right.
How about that?
All right, great job. Thank you very much. Group number 1. Group number 2, come on up. Ready?
Your classmates have the floor.
All right, everybody. Please go ahead.
Today, our group learned that during the experiment, every time we added a battery, the volts got higher by 1.5 volts and sometimes 1.
Great, great, great. All right.
We were also able to predict and troubleshoot when it didn't work. It was tricky to hold the batteries together because it kept moving.
If the panel doesn't stay with the sun, it can't stop.
In order to power the fans, we have to have somewhat perpendicular to the panel. We were able to power 2 fans from the same light source.
Very
Way to go.
good.
Great job. Give them a hand. Great job, Janet. Hey, hey. Right on. Come on up. Group number 3 over here. All right, come on up. All right, you got it. Come on up. All right, make sure to speak it out there. Go ahead.
A solar panel depends on the angle to get more sunlight.
Great, great, great.
Solar energy can help the planet.
Yay. All right.
The sun is a renewable source of energy.
Excellent.
The closer the sun, the more energy the panel.
Cool.
Each battery has its own amount of voltage. The more batteries, the more voltage.
Yeah.
We can test the voltage in the battery.
Certainly can. Great job. Great job. Great job. Great job, team. Hey! All right, you guys. Our next group, come on up. Come on up. Yay! All right.
Today we learned there's more voltage in 3 batteries than a 12 battery.
Oh, nice. They did an excellent job.
More batteries more voltage.
With solar energy, it can power the microwave or refrigerator.
We don't always have a sun, so we have to learn how to store the energy. Have you ever tried to figure out why it's not Fossil fuels are always going to be here, so we need solar energy.
Anything else? Great job, great job, great job. Yay! All right. Analysis. Thank you very much. We learned a lot of things. People did batteries. They talk about you can power batteries in cars, right? There's cars that are electric cars, right? Isn't that amazing? You can use the sun. They can get charged. Just like you can charge a battery. It's in your car. It can have your car to run. So it's amazing. You all did incredible work. A lot of analysis. Really good questions. You solved. You went beyond even what was asked. So thank you very, very, very much. Now I'm going to pass out a couple of things. I want to ask you if you have any final questions before I pass this out, and just give you another thanks before we're done for the day. Any other questions? Please.
Let's told that the solar panels left a lifetime of going up to 10 years.
Well, it's interesting. Their warranty, like these, there's what they call a warranty, how they're kind of protected, right? And for like 25 years, the warranty for 25 years, but they can last even longer than that. And one of the reasons that they can last so long is because they don't have moving parts. That's a big part of it, right? Things with moving parts tend to break, right? So there's a little more to keeping them up and functioning. But solar, it stays there as you saw with the sun, it just stays there. As long as it's all airtight. And they do testing to make sure it can take certain levels of rain and heat and snow and even hail, right, hitting it. So they last for a long time. So thank you. All right, everybody, thank you very, very much.